Hello students, this video lecture is about finding solution of non-homogeneous linear differential equations with constant coefficients. Solution of non-homogeneous linear differential equation with constant coefficients. The general solution of A naught d power ny by dx power n plus A1 d power n minus 1 y by dx power n minus 1 plus etc. plus any equal to x is given by y equal to yc plus yp, where yc is the complementary function of the homogeneous linear differential equation A naught d power ny by dx power n plus A1 d power n minus 1 y by dx power n minus 1 plus etc. plus any equal to 0. Yp is the particular integral obtained from x. To find the particular integral Yp, consider the equation A naught d power ny by dx power n plus A1 d power n minus 1 y by dx power n minus 1 plus etc. plus any equal to x, where capital X is any function of the variable small letter x. And this differential equation can be written in the form as A naught capital D power n plus A1 capital D power n minus 1 plus etc. plus An times y equal to x, where capital D means d by dx. This equation A naught d power n plus A1 d power n minus 1 plus etc. up to plus An can be written as Fd. So, this equation reduces to Fd into y equal to capital X. Now, particular integral Yp is equal to 1 by Fd of x. Here see y equal to 1 by Fd of x. So, that is the particular integral. So, we have written here Yp equal to 1 by Fd of x. To show that 1 by d minus alpha into x equal to e power alpha x into integration of capital X e power minus alpha x dx, where capital X is a function of x. Answer. Let us take capital Z equal to 1 by d minus alpha into x. Now cross multiply z and d minus alpha to get d minus alpha into z equal to x. Now dz means that is dz by dx because capital D is d by dx. So we get dz by dx minus alpha z equal to x, which is a linear differential equation in z. To solve the linear differential equation, first we find out the integrating factor. Integrating factor equal to e power integral minus alpha dx. Minus alpha is obtained from the coefficient of z. So, e power integral minus alpha dx, that is e power minus alpha x. The solution of this linear differential equation is given by z into integrating factor, that is z into e power minus alpha x equal to integration of the right hand side function, that is capital X into integrating factor. So integral x e power minus alpha x dx. So the solution is given by z into e power minus alpha x equal to integral capital X e power minus alpha x dx. Now divide Throughout by e power minus alpha x, we get z equal to e power alpha x into integration x into e power minus alpha x dx, because 1 by e power minus alpha x dx is e power alpha x. So now replace z by 1 by t minus alpha into x, we get the desired result as 1 by d minus alpha into x equal to e power alpha x into integral x e power minus alpha x dx. Thank you for watching this video. Thank you all.